In this lesson, we're going to discuss significant figures, or in other words, how detailed should a number be. So, significant figures are related to precision. And they are digits that are considered to be known confidently. So I'm going to give you an example of a number to varying degrees of precision or with varying degrees of significant figures. So the number 1246.234, we can also report that as 1246.23 or 1246.2 or 1246 or 1240 or 1200 or 1000. So all of these could be talking about the same value, the same measurement, the same variable, but they're to different degrees of precision. This top one is most precise, this bottom one is least precise, and just as we went along they got rounded. I guess technically this should be 1250, and then depending on when you're rounding, this one might be 300 or not. But the significant figures, we basically count all of the digits that are non-zero. And there's other rules here. So this first one has 1, 2, 3, 4, 5, 6, 7 significant figures. The second one has 6, 5, 4, 3, 2, and 1, respectively. It gets a little weird. This is most easily done with scientific notation. So if I write like 1.00 times 10 to the third, this has 3 significant figures because 3 numbers are written down. 1.01 times 10 to the third has 3 significant figures. If I were to write all of these in terms of scientific notation, they would all be 1.246234 times 10 to the fourth, 1.24623, etc. And you can see how it's easier to see how many significant figures we have. If you need a review, this is something I'm going to assume most people have done before, but if you need a review, catch me and we will talk through it in more detail. Oh, this is a little bit weird, but to clarify, integers are considered to have infinite significant figures. So the number 2, as in 2 of something, is considered to be exactly 2, which means it's 2.0000000 all the way out to infinity. And that will matter for some stuff that we'll do in the next slide here. So when we combine measurements, how do we deal with the significant figures? Because remember, we're talking about how precisely or how confidently we know a number. So if you add or subtract, find the least significant figure and report to there. So this is easier to see with an example. If I do 1234.46 plus 1200, actually let me do these in scientific notation so it's easier to no, we'll do it this way. 1200.3, well, we know that our least significant figure is this 3 right here. I know the first number more precisely, so when I write my answer, I'm going to write 2,434. First, I use all of them, so I'll get 7, 6, but then I only want to report to this first decimal place, so it'll be 2,434.8 would be what I'd report. So this one, they were only off by 1, but if they're off by 2, 3, 4 significant figures, then you just carry that through, same logic. Multiplication and division, use the number of sig figs from the value with the fewest. So for example, if I do 3.5 times 2.242, well then my answer would be reported to two significant figures. Let me actually make this a little more interesting. Let's call it 4.242. So 3.5 times 4.2, that's going to be 1214 plus about 0.7. So this is going to be 14 or 15, I'm not quite sure what. But it's going to be like 14 point something or 15 point something. Either way, all I'm going to report is the 14 because 3.5 has two significant figures, 4.242 has 4, so my answer should just have the 2. So be 14, or like I said, if it rounds up a little bit, it should be 15. Again, if this is going by a little quick, get in touch with me and I'll help explain some more. When we have exponents, then it's just like multiplication and division. You do whatever the fewest number is. So it's like 3.5 to the 2.23, then we'd report it to two significant figures because we have 2 here. This is one of the places where it's important to remember, say if it's 3.5 squared, then this 2 is actually 2.0000000 infinity zeros. So this is actually, we'd report to two significant figures.